Here's problem number 5 from section 7.2. We are going to try to find the area of this blue region. I am going to draw a typical rectangle, which looks like this. So the area can be found by taking the integral of looking at the height of this rectangle. Well, at the top of this rectangle, we have y equals x to the fourth minus 2x squared. The bottom of this rectangle, oh, I'm sorry, I have that backward. The top of this rectangle is on this curve, which is 2x squared. The bottom of this triangle is on this curve, and that curve is 4x cubed minus 2x squared. All right? And then the width of this rectangle is measured in the horizontal direction, so we're going to be using the differential dx to describe that. And we'll say, well, what's the lowest value of x? What is the highest value of x for our upper bound? And there we have an integral expression that represents that area. But because both of these functions are even functions, there is a symmetry about the y-axis, so we can also rewrite this as the integral from 0 to 2 and double the area. And I'm going to distribute the negative sign through. And let's combine like terms. For, try that again, for x squared dx. All right, now let's go ahead and do that antiderivative. 2 times the quantity, the antiderivative of negative x to the fourth is negative 1/5 x to the fifth, plus the antiderivative of 4x squared is going to be 4 divided by 3x cubed, and we're going to evaluate this from 0 to 2. Okay, evaluating this on the top end, I'm going to get negative 1/5 times 2 to the fifth plus 4/3 times 2 to the third. And when I evaluate this on the bottom end, I'm going to get a lot of zeros. Third. I recognize I got a lot of zeros there, so I'm going to ignore this part because it doesn't add anything. Coming back here then, I've got 2 times quantity. 2 to the fifth is 32. 2 to the third is 8 times 4 is 32. Oh, that's to the third, not to the fifth. So, cleaning up from there, I've got a common denominator of 15. So, I'm going to end up, let's do this one first. Multiply both top and bottom by 5. And I end up getting 160 divided by 15. And then I'm going to subtract off, and I'll do this one next, subtracting off 96 fifteenths, giving me 2 times 64 fifteenths. And multiplying the 2 times 64, I get 128 fifteenths. And that's the answer.